Welcome back. Today we're looking at trig identities, and trig identities is one of the things that people struggle with. It's not super important really, but because we're talking about identities, we're really practicing knowing all of our different identities, the ones that we're being given, but also being able to do our algebra really well. Right, so we're going to be using our algebra concepts, more so algebra 2 concepts, to solve these. Well, not really solve, but we're trying to show that two things are similar when we're talking about identities. It's a new skill, but it's a bunch of old skills that we should have that some of us might not have, that we're going to combine together. So we already talked about the quotient identities before, right? So this is just saying that the tangent is the sine over the cosine. Cotangent is cosine over sine. The reciprocal identities as well. We know that the cosecant is the reciprocal of sine. The secant is reciprocal of cosine, and cotangent is reciprocal of tangent. The ones we're adding in today are the Pythagorean identities. So sine squared plus cosine squared is equal to 1. This is the major one. Always be on the lookout for anytime you have a sine squared plus a cosine squared, because you can always switch that out with 1. I cannot stress how important it is for you guys to start looking at that thing, that this identity, sine squared plus cosine squared equals 1, and trying to be aware of it as you're working through these problems, because it's going to help you out tremendously. These other two are also they're also identities that we use, but the sine squared plus cosine is the most common one, and these other ones are derived from that top one. We're not going to get into it today and show you how they're derived from it, because that's probably not interesting to you, but they're all the same formula is what I'm trying to say. It's just that they're in different forms. And likewise, you might see these, and I don't want to confuse you too much, but you might see these in similar forms, but just rearranged. So let's say we took sine squared plus cosine squared equals 1. Well, what if I wanted to move the cosine over algebraically? As long as I'm not breaking any algebraic rules, we can have the same identity. But this time, if I subtracted the cosine from the left and brought it over to the right, this is also another acceptable form that you might see where we can replace it, right? So it's a little bit complex. It's new, and it's going to be harder to see it now, but the more you try to and try to apply this concept about replacing and being able to switch stuff out, then the better off you'll get in the end. So it might be frustrating, it might be hard to see at first. I know it is for a lot of us, but yeah, just keep at it. So at this point, what you probably want to do is you want to find a file online through Google at through some place where it's a trig. Oops. Try to find a trig cheat sheet. There's one I like to use, but whichever one is best for you. And the reason we want to do that is because it's going to list all the identities. It's probably going to give you a unit circle on there. It's going to be like a one-stop place for all your trig needs. If I remember, I'll try to post one in the materials section of your classroom, but that doesn't have to be the only one you use. The one I use is because it takes up less paper and everything's right there. You might find one that works a little bit better for you. So go ahead and search trig cheat sheet, find one that you like, and then save it and have it for you as you do your work from now on. Okay? So these problems are not really difficult. It's just we're approaching these from a different angle and something that you probably have not done before. So it's saying for the first example, simplify. Now the number one hint when it's asking us to simplify anything, the best way to do that is, if you're stuck, start by changing everything to sine and cosine. Right, that's the number one hint I can give you, and it's a struggle, but if you do this, then at least if you don't break any algebraic rules, things are going to start simplifying themselves. All right, so we're looking at cotangent and cosecant. So neither of those things are sines and cosines. But if we go back here, I can change my cotangent into cosine over sine, and I can change my cosecant to 1 over sine. All right, so let's switch those things out here. So this thing is going to be cosine theta over sine theta, and cosecant is going to be 1 over sine theta. All right, so step 1, mission accomplished, right? But now we're dealing with something that's a lot more complex looking than what we started off with here. But not to worry, because we kind of talked about this before, where we said anytime we have a complex fraction, we're not going to panic anymore. We know what to do. So we're going to simplify, and specifically in this case, we're going to change the complex fraction. Right, we know that we're going to keep the numerator as is, but a complex fraction, or any fraction really, just means that we're multiplying by the reciprocal of the denominator. So the reciprocal of the denominator, all right, we take the denominator and flip it over, is sine theta over 1. Now something really cool happens here, because now the sines cancel out, and then cosine over 1 is just cosine. Right, so I'm a math nerd. I think that's super awesome that this complex thing, or even this complex thing, came out to something so simple. You guys might not think so, but that's kind of the beauty of math. We can use these rules to make something complex simple. All right, let's try another example. So this one says, show that cosine theta over 1 plus sine theta is equal to 1 minus sine theta over cosine theta by multiplying by negative 1 minus, sine theta in numerator and denominator. Now the cool part of this is they're telling us exactly what to do. And then it's saying that show that the left side is going to be equal to the right side. So this is one of the cases where we're going to show that something is equal to something. So what we want to do here is we want to only work on one side, and it's kind of telling us exactly what to do. So it's saying multiply that thing in the numerator and denominator here. So we're going to do 1 minus sine theta times cosine theta over 1 minus sine theta times 1 plus sine theta. And they said we want to show that it's equal to the right side. So we're not going to touch the right side at all. But what should happen in the end is that the top should look like the bottom. Okay? Actually, did I say top should look like the bottom? The left side should look like the right side. All right, so what we're going to do here is we're going to multiply this bottom. We could multiply the top, but it's just going to make our life more complicated. Notice that we have this thing, which is this thing, so we don't want to really mess with that. We want to keep that 1 minus sine theta there on the left-hand side. We hope that the cosine will cancel out somehow. Now, if we multiply this bottom, and this is just foiling, right? FOIL method or distributive property, we're just going to multiply this whole thing out. And what we're going to find is, because we have the minus and the plus, and the 1 and the sine are the same in both of them, this is like a difference of squares. So when we multiply this out, what we're going to get is 1 minus sine squared theta. The top hasn't changed. All right, so for those of us who need to see what that looks like, if we do difference of squares, right, and we multiply it out, then we get the first thing squared, then we get the middle part positive, we get the middle part negative, and then the last part squared, right? These things cancel out. We just end up with a squared minus b squared, right, which is why we get 1 minus sine squared. Okay, so that's a little bit tricky, right? We have to multiply it out. We'd end up with this. It's not too bad, even if you did the whole thing out. Just remember that we're using the FOIL method or distributive property. Now here's the part that's tricky. So remember I said be aware of cosine squareds, the ones and the sine squared. Well, this is actually a version of this, right? Which looks very similar to this, except for all I did was move the sine squared. So if we took that and we said, all right, instead of moving the cosine squared over, let's subtract sine squared. So cosine squared theta equals 1 minus sine squared theta. Oh wait, this is exactly what we have here, right? We have a 1 minus sine squared theta, and we know that that's equivalent to cosine squared theta. So we're going to replace that. Let's change colors again. We're going to replace the denominator with cosine squared theta. Okay, so we're getting closer to this answer here. Now notice the bottom is cosine squared. We have a cosine on top. Remember again, cosine squared just means cosine theta times itself. So we can get rid of the one in the top and one of them in the bottom. And we end up with 1 minus sine theta over cosine theta. And now we're done because the left side is the same as what we had on the right side. All right, so when it says to show and we have an equal sign, what it's asking us to do is work on one side, use our identities, use our algebra, and try to get the left side to look like the right side. All right, so that's a new concept, right? But it's going to use all of our algebra skills. It's going to ask us to rely on knowing how to use the identities from our trig, the ones you can find on your cheat sheet and the ones that we've written down in the beginning of this lesson. And it's a lot of algebra, it's a lot of math, but you guys can do it. So we're starting off in small steps, and again, the more you see it, the more you're comfortable with it, the better you get at it. Okay, let's try another one. So it's asking this time simplify 1 plus sine u over sine u plus cotangent u minus cosine u over cosine u. All right, so one of the things that we can do here is, so first of all, we can change all the things to sines and cosines, right? We can definitely do that. But before we do that, let's do this and do common denominators, right? Common denominators. And the reason we're doing that is because notice we don't have an equal sign, we have a plus sign. So if we're adding things, eventually if we're going to add two fractions, we want to have common denominators. So let's see what happens if I make common denominators here. Or let's first talk about what the common denominator would be. So I have a sine u here and a cosine u there. Well, if I want to make the left side look like the right side, then I'm just going to do cosine u on top and bottom. And I'm going to also put parentheses here because it's easy to forget that the fraction bar actually has, it's like a grouping symbol. It's like invisible parentheses there. So if I'm multiplying the whole top, so I need to put parentheses there. Now, same thing on the bottom with the cosine u. If I want to make that right side look like the left side, I need to multiply by sine u on top and bottom. Again, we're putting parentheses just to remind ourselves. Okay, so now that we have common denominators, then we accomplish step one, right? Everything is going to be common denominators here. Okay, so what we can do here at this point is write this as one big fraction. And we can also, at the same time, I guess, multiply this stuff out. Yeah, let's do that first. Let's go ahead and multiply this stuff out and make one humongous fraction, right? Because we can add it now that we have common denominators. So the common denominator would be cosine u, sine u. On the top, we have cosine u times 1, which is just cosine u. Then we have cosine u times sine u. Let's keep this uniform. So cosine first. Cosine u, sine u. And then on the next part, we have sine u times cotangent u. So cotangent u, sine u. And then the last part, negative cosine u, sine u. All right, so no different from algebra. It's just that rather than just using one variable, we have sines, cosines, we have cotangents, and the thing with those is that they can change around. Now, let's simplify some stuff here. So if you notice that we have cosine u, sine u, and then a minus cosine u, sine u, anything minus itself is 0. So that part's neat. That kind of like just goes away. Let's rewrite this stuff this time. At this point, now let's do the changing everything to sines and cosines because I'm kind of stuck there. So let's change cotangent into, well, let's rewrite this. Let's change colors too. So we still have this cosine u. We're rewriting this cotangent as cosine over sine. Okay, and the cool part about that is this sign and this sign can cancel. One's in the denominator, one's being multiplied, so it's technically in the numerator. If it helps, you can also do that. Right, so we really only have cosine u plus cosine u. Oh, that's 2 cosine u's. And on the bottom, you have cosine u sine u. And guess what we can do with the cosines? One's in the numerator, one's in the denominator. It's all multiplications and divisions. Those cancel. So this whole thing, that whole complex thing ends up as 2 over sine u. All right, so from this whole big ugly thing that we have 2 fractions, additions and subtractions in the numerator, different denominators, from all that mess we ended up with this very simple 2 over sine u. Okay, so again, the math nerd in me, and maybe for some of you guys too, was like, wow, look at that. And even though it might be overwhelming to you right now because like, wow, that's a lot of steps, there's a lot of things going on. Again, the more you practice it, the more you look at the different strategies to go about doing it, the better you get at it. And you will hopefully be able to do this on your own pretty easily after some practice and working through this stuff. Okay, so let's go on to the last one. So the last one is asking us to simplify sine squared v minus 1 over tangent v sine v minus tangent v. There's a couple things that are going to be happening in here. So let's just kind of jump into it. So the first thing we want to do is let's look at the bottom. Notice that we have common tangents here. So what we want to do is factor those tangents out. So let's do tangent v, right? We're factoring in the bottom. And then if we do that, then we have a sine v left over. And when we factor out and we don't have anything left, we got to leave a 1 in there because technically we're dividing it out. So when we do tangent v divided by tangent v to bring it out, we still have a 1 there. Now the top, we can do it at this point. We might as well, even though it's kind of like 2 steps in one. Notice this is a difference of squares. Sine squared v is a perfect square. Its square root is sine v. Also 1 is a perfect square because the square root of 1 is 1. And we have a subtraction in between. So difference of squares. I know the kids who were in my Algebra 2 class, I kept asking you guys, please be aware of difference of squares. It's going to make your life super easy later on. I'm sure some of us have forgotten it. I'm sure some of us may not have learned it in the first place. But anytime we have perfect squares with a subtraction in the middle, we're going to be able to factor that really nicely because we know that it's going to be, oops, there's not a square there, sine v plus 1, sine v minus 1. Every time. It's going to be the square root of the first part, the square root of the last part, 1 with the plus, 1 with the minus. So that factors out really nicely. Now, the reason we did that is because now we can cancel out the sine v minus 1 since they're common in top and bottom, and it's only multiplications and divisions between the parentheses. All right, so we end up with just sine v plus 1 over tangent v. Technically, you might be able to make this a little bit simpler. I'm going to say we can stop there, but for those of us who wanted to see what it would look like if we simplified it some more, yeah, let's go ahead and do it. All right, so at this point, because tangent is not in sines and cosines, we can go ahead and do that. So this can be rewritten as tangent is the same thing as a sine over cosine. Right, so now look, we're stuck with this complex fraction here again, and we're not going to freak out because we know exactly what to do. We know that that's messing it up. We got a fraction within a fraction, so we're going to take the numerator times the reciprocal of the denominator. So, oops, sorry, the reciprocal would be cosine over sine. Now when we multiply this out, it's going to get messy because cosine times sine divided by sine, right, because we have this sine as well, plus 1 times cosine over sine right, these signs will cancel out, and we end up with cosine v, right, plus, and then I guess at this point we can change cosine sine back to cotangent. Right, so it's a little bit simpler than what we had here, but I'm saying at that point you could probably stop on the top. Right, we canceled enough things, it looks good enough. Okay? And I believe that's it. Good job today. I know it was a lot of stuff. There's a lot of things to think over, a lot of new strategies to use, but the only way we're going to get better at it is if we practice it. And I promise you, the more you do, the easier it's going to get. The more things that you see, the more strategies, the more times you use a strategy, or the more times you see a particular type of problem and figure out how to go about it, the better you're going to be. And all this algebra stuff, I mean, if you can do this type of algebra, then you should be prepared for any of the types of math that you might see going forward. And so it's kind of like a buffed up version of Algebra 2 type things thrown in with the trig identity stuff. But if you can do this kind of math, you are definitely prepared for anything that you'll see in higher levels of math. Those of you who are planning to do calculus, though, really practice your math, because the sad thing is, for the most part, the AP Calc students, they don't mess up on calculus concepts, because in calculus there's only like a handful of concepts that you really need to use that are new. It's just that they get mixed up in the symbols for one, but we work through that. That's pretty simple. But the thing they get caught up on is the algebra stuff. So make sure if that is your goal, that you want to get to calculus, that we clean up all this stuff about the algebra and especially the harder algebra, because no one's going to help you do the algebra when you get to that point. They're just going to assume you know how to do it. All right? Anyways, good job. I know it's going to be tough, but please work through these. We're going to work on these types of problems over multiple classes. So good job today. Make sure you have any questions. If you have any questions, please bring those in. We can talk about them next class. All right, good job.